Okay, you guys asked for it, so I'm going to do my best to provide. I didn't provide this for Unit 1 just because it was so short. Maybe I'll go back and change that for future classes, but you guys asked for the new test for Unit 2. Can you create a review for it? Okay, so I'm going to do my best to cover as much material in this review as possible. And while covering this material, I'm going to see if in the play bar on the YouTube video if I can put it into chapters. So if there's any specific part you're struggling with, you can just scroll through the chapters and see what's labeled and see, oh, I need help with the velocity over time equation. I need help with the meaningful equation. I need help converting from a position over time equation to a velocity over time equation. So look down there. Otherwise, I'll just put in the description where each section is, and then you guys can figure it out from there. Otherwise, I would recommend watching the entire video because I do think we're going to be covering a majority of what will be on the test. Okay, and this looks like a lot of information. We're just going to take it piece by piece. I'm going to start up here where I said Unit 2 review. That's going to be our starting point. And the first thing we started with this unit was relating to position over time equations. Okay, not equations, graphs. And so first, I'm going to highlight this graph over here. This is a position over time graph. Okay, it's covering information based on two objects. Okay, so we have object 1, object 2, and so I need you guys to be able to look at this graph and be able to determine, okay, based on the information that I'm seeing, which object is traveling faster, which one's traveling maybe more slow, which one's traveling forward, which one's traveling backwards, which one is getting a head start. Okay, it's not at the 0 starting position. Which one has a y-intercept? Okay, aka got a head start. So as always, I like to emphasize that when you're looking at these graphs, try to think of the x-axis as if that's the starting line. And then I like to think that if you're up here, okay, toward the top of the graph, you're more at the finish line, okay? And then if you go below the x-axis, then you're more behind the starting line, okay? And so how am I going to describe this? Well, object 1, I see object 1 is going up, okay? And so that means it has a positive slope. So I'll write that right here. And let's do blue. So this has a positive slope. And when you have a line with a positive slope on a position versus time graph, what that indicates to you is it's moving forward. It's moving forward. Now, this other line has a negative slope, which I'll make in red. And if it has a negative slope, what that's telling you is the object is moving backward. It's moving toward the starting line. Okay? Now, without any numbers, is there an easy way to determine which one is faster? Well, that's hard to say because if we don't have any numbers, okay, if we don't have any labels like for time, 1 second, 2 second, 3 second, for X, if we don't have 1, 2, 3 meters, we can't really determine which one may be faster because I would say this line looks pretty steep. This line looks pretty steep. This line looks pretty steep, okay? And so the steepness of the line determines how fast the object's going. The more steep the line or the more vertical the line is, that's the faster it's going to be going. The more horizontal, aka side to side, the line is, the slower the object is going. And how I like to think about it is, if the line looks more like your x-axis, it's going slow. If it's more like your y-axis, it's going fast, okay? And so both of these are kind of right in the middle. This is kind of in between being like the x-axis and it's kind of in between being like the y-axis. So it's going pretty fast. And I would say the same thing for this guy right here. This guy is kind of like the y-axis. It's almost up and down, but it's also kind of like horizontal a little bit. So they're both relatively going the same speed, okay? But they're just heading in opposite directions. One person's going forward, one's going back. Now, how about starting position? Again, I like to think that this spot right here, I will color it yellow, I believe. Okay, I like green. This spot right here, I like to think is the starting line. This entire spot, I like to think is the starting line. So object 1 started at the starting line. It started at position 0. Object 2 started closer to the end of the graph, and I like to think of this like the finish line, like the end of your destination. Object 2 started, okay, past the starting line, more toward your finish line, and is now heading toward the starting line, toward position 0, okay? So how is that going to look on a velocity over time graph? Velocity over time, okay? So we're going to have two lines, one for object 1, one for object 2, and I'll try to color coordinate them based on how I've been labeling them. So let's go with object 1 first, okay? Forward velocity, we are positive slope. So as a reminder, your velocity over time graph, all you are transferring over to this is your slope information, okay? So when it comes to making your velocity over time graph, you're going to take your position over time graph, whatever objects you're studying, whichever lines you're studying, you're just going to be taking their slope and you're going to be moving them over here. Now, object 1 has a positive slope, but I don't know how positive since we don't have numbers, but I can just roughly guesstimate, okay? Since it has a positive slope, okay, and it's not quite vertical, but it's not quite horizontal, it's right in the middle. I'm going to say its positive slope is right in the middle of the positive region, okay? And so I'm going to say this is object 1, and it has a positive slope, and so I'm going to put a horizontal line for velocity in the positive region of the velocity versus time graph. So the top half is the positive region, the bottom half is going to be the negative region. Okay. Now the question is, why is the line horizontal? Okay. Why did I just do the same horizontal line for the entirety of the graph for object 1? Well, if you look, this is a pretty darn straight line. It looks like the velocity, the slope of this line, is the same throughout the entire graph for object 1. If the slope is the same, then it's going to have a horizontal, okay, line, a flat line on the velocity versus time graph. Okay, so object 1 had a positive velocity, a positive slope, so I'm going to make a constant positive velocity on the velocity versus time graph. Now, how about for object 2? Object 2 is in red. It has a negative slope, so I'm just going to be putting it in the negative region of the velocity versus time graph. I'm going to put it right here. And it's a pretty straight line right here, so its slope is pretty consistent. So that means the slope here is going to be the same. Whatever value it is, if it's -1, -2, it's going to be the same negative slope throughout the entirety of the object 2. So object 2 has a negative slope, and the slope was the same for the entirety of this line. And so we're saying that the slope was the same through the entirety of object 2's line for the position over time graph. So this is the negative region. Okay, so that's describing position versus time graphs and converting a little bit to velocity versus time graphs. Now, I want to give you a tough one. Now, what these lines indicate right here is that these two lines are parallel. They will never cross. They will never cross. And so my question is, how's that going to look on the velocity versus time graph? Because if they're parallel, if they have the same steepness, that means these objects here are equal when it comes to their velocity. They have the same velocity because they have the same steepness. Okay? So how am I going to graph that velocity over here if they have the same exact velocity and they both are moving up? So that is positive. This is a positive velocity for both of them. Okay, how's that going to look? Well, it's just going to look like a positive velocity line in the positive region of the velocity versus time graph. Since the slope was the same, it didn't change, they're both just straight lines. That means the slope over here is going to be the same value throughout the entirety of the velocity versus time graph. And since they share the same velocity, share the same slope, that means for this line right here, this line is going to represent object 1 plus object 2. Because since they have the same exact slope, same exact velocity, their lines would be stacked on top of each other. Okay? So, again, converting from position over time to velocity over time. Okay, this is much more of a basic understanding of this. Okay? So, let's keep moving forward with this concept. So right here, we have a more complicated velocity over time graph. Now, we just did position over time and we converted to a velocity over time. We got to be able to do the reverse. So right here on this graph, I have a velocity over time graph. And down here, I have a position over time graph. So we need to be able to convert this into a position over time graph. We have to work backwards. Now, here's a very important thing that we labeled in the notes. You can never, ever take a velocity versus time graph and determine where exactly is your starting point / ending point for your position over time graph. Okay, we have no idea based on this graph where we started. Did we start at the 10-meter line? Did we start at the 0-meter line? Did we start at the -6-meter line? Okay, which line did we start at? Did we start at the starting line? We don't know. We can't tell from this because we only know from this graph how fast. Okay, how fast and in which direction this person or object was traveling. So, for lack of a better way to put it, I just have to choose the starting point, okay? So I might choose a starting point to be 10 meters, 0 meters, negative 10 meters. I might choose any of these because we can't figure it out, okay? So what I'm going to do first, before I choose a starting point, is I'm going to try to figure out what is the slope of my lines I'm going to be putting on my position versus time graph. I'm going to be figuring that out from here first, okay? So I'm going to figure this out here first, then I'm going to start working my way toward my position over time graph, okay? So anytime your line is on the time axis, right here, that means your slope is 0. So for right here, my slope, I'm going to put in red, is going to be 0, okay? 0 meters per second. Now for here, it went up to 2, and this was for 1 second, so that means my slope was 2 meters per second. Down here, we hit 0 again, so that means it's 0 meters per second yet again. Now from 3 meters to 5 meters, we hopped up to 4 meters per second. 4 meters per second. And then from 5 seconds to 7 seconds, we went down to negative 6 meters per second. And last but not least, 7 seconds to 10 seconds at the very end there, we went back to 2 meters per second. So how is that going to look when I start graphing this on my position over time graph? Well, I'm going to use these slopes, and these slopes will help me make my lines. There's also another way you could do this, and we discovered this on Tuesday. You can also find the displacement of your position based on the area between your line and your time axis. So for example, if I look here, the distance between my x-axis, my time axis, so the difference between my black time axis and the line, which is my velocity, my blue line, is 0 to 2. So that means it's 2 meters tall over 1 second. So that means I was displaced a positive 2 meters. Okay. Now, right here, we went up 4 meters, and this lasted over 2 seconds. So 4 times 2, I must have been displaced 8 meters worth. Down here, we went down to the negative 6 spot, and this was over 2 seconds, okay? So we have to take that negative into consideration, so that means negative 6 times 2, I was displaced negative 12 meters. And last but not least, from 7 to 10 seconds, we went up to the positive 2 meter spot. So from 7 seconds to 10 seconds, that's 3 seconds. 3 times 2, that is a positive 6 meters I was displaced. So I think using this information is much more easier than using my slope. Okay, I'm going to show both of them. So now that I have this information, I can start making my position over time graph down here. Okay, so I'm just going to choose, again, you choose a starting point. I'm going to choose it because we can't figure out what the starting point was based on our velocity over time graph. So I'm just going to choose a position. I'm just going to say I started at the starting line because I'm no cheater. Okay, I didn't get a head start. So I'm going to start at the starting line. Now, for the first second, on my velocity versus time graph, it says our slope was 0 meters per second, 0, which means you're not moving, which means my position's not moving. So that means that's going to be a flat line right here. And you know that is correct because a horizontal line means it has a 0 slope, and that's what states here. My velocity, my slope was 0. Now, from 1 second to 2 seconds, it said I went up 2 meters. So what I'm going to do is I'm going to go over 1 second. So for every second I went up 2 meters. That means I'm going to go up 2 meters right here. And I'm going to connect that line. And that means my slope right here is also a positive 2. Okay, just like it is here, positive 2 meters per second. Now it says from 2 seconds to 3 seconds, it says I have a 0 velocity. That means my object stayed still or stood still. And since we have a horizontal line has a slope of 0. Perfect, that looks right. Now 3 seconds to 5 seconds, it says from 3 seconds to 5 seconds, I went up 8 meters. So I'm going to go to the 5 second spot, and I'm at 2 meters right now. I'm going to go up 8 meters until I hit the 10 meter spot, right about here. I'm going to connect my line. Okay, so if you go over 2 seconds over, and you go up 8 meters, so you went up 8 meters over 2 seconds, your slope is 4 meters per second, and that's right so far. So all of this is looking solid, looking pretty good. Okay, I'm going to erase that. Beautiful. Next, it says from 5 seconds to 7 seconds, I went down 12 meters. So I'm at the 10-meter spot. So in 2 seconds, I'm going to go to the 7-second spot. I'm going to go down 12 meters. So I'm at 10 meters. So if I go down to 0, that means I went down 10 meters so far, but I need to go down 12. So I need to go down 2 more meters at the -2 spot, which is right here. So at 7 seconds, I go down to the -2 meters location. And I went all the way down here behind the starting line, technically. Okay, so since I went down 12 meters over 2 seconds, down 12 meters over 2 seconds, that means my slope was -6 meters per second, which is correct based on what I have here. So that's good. Okay, last but not least, it says for the last 3 seconds, from 7 seconds to 10 seconds, I went up 6 meters. So I'm at the -2 spot. I'm going to go to the 10 seconds. So 1, 2, 3. Now I'm at -2. It says I went up 6 meters. So I'm going to go to 0, 2, then 4. 4 meters. I'm going to connect this. Okay. So far, that means I went up 6 meters. I followed that rule. And if I went up 6 meters over 3 seconds, that means my slope must be 2 meters per second in the positive direction, which is correct based on what I have up here. So that's good too. So there's 2 methods to go about this. You can either find the area between your time axis and your velocity line to figure out how much you're going up and down by, or you could simply just use the slopes. You could go over 1 second, up 2 meters. You could go over 1 second, up 4 meters, and you're going to do that for 2 seconds. So for 2 seconds, you're going to go over 1 second, up 4 meters, over 1 second, up 4 meters, and you can go that way. Okay. So when in doubt, if you see a staircase method, I like to call this a staircase method, where you jump, take a step up, step down, big step up, big step down, big step up. Okay. If you see that, okay, what that indicates to you is you're probably dealing with the velocity over time. Okay, velocity over time graph. If you see something that's more going up, kind of like hills and mountains, you're probably dealing with the position over time graph. But just watch those axes. They're usually labeled. This one will be labeled velocity over time, aka V over T. This one will be distance over time. This one will be called X over T. Okay, so just be careful about that. Make sure to watch that. Next, we're going to take a little bit higher. Beautiful. We have a position over time graph. I know it's a position over time graph because we have an X here and we have a T here. So position meters times seconds. And what we're going to try to pull from this graph is the average speed, the average velocity, and the meaningful equation. Okay. So, and we have numbers. So there's a lot of numbers we could be inserting to our meaningful equation as well. So I'm going to start with average speed. To find average speed, I'm going to be writing in, let's go with blue. To find average speed, you need to find the distance traveled over the amount of time of the graph. Okay, so we're going to find the average speed for the entirety of this graph. So we started at 40 meters. We went down to 0. So that means we traveled 40 meters. Now here's a reminder. Distance does not care about a positive or negative sign. I don't care if you went down 40 meters, up 40 meters. We just care about the raw number, okay, the absolute value of the number of 40 meters. So we traveled 40 meters in 8 seconds. So 40 divided by 8 is going to be an answer of 5 meters per second. That was our average speed, okay? So to find distance, you need to add up how much you went down in your line and how much you went up. Luckily, this graph was very easy. We just went down 40 meters. And so our distance traveled was 40 meters. We don't care about that negative sign. We don't care about it, okay? We just want the raw number. So distance traveled, we're going to take the distance we travel down and up our graph, okay? So distance divided by time. Now, how is average velocity different? This is our displacement over time. And displacement, how I like to put it, is displacement doesn't care about the journey. It just cares about the destination. It cares about where you started and where you stopped. We started at 40 meters. We ended at 0 meters. So it just so happens that our velocity is going to look very familiar, very similar, okay, to our speed. Okay, since we went down 40 meters, we're going to say negative 40, okay? Displacement does care about whether it's a positive or negative 40 you traveled. From our initial value, which was 40 meters, we traveled to 0. So we went down, we started high, we ended low, so we went down 40 meters, so we're going to say negative 40 meters. Again, distance doesn't care about plus or minus, but displacement does. Okay, speed doesn't care about plus or minus, but velocity does. Now, we traveled negative 40 meters over 8 seconds. Okay, so what's our final answer? Our final answer for this, I'm going to insert right over here, is negative 5 meters per second. That was our velocity. Okay, so again, distance, I'll do distance in dark blue. Distance cares about the journey. Where did you start, where did you end, and where did you go along the way? Versus in red, red is going to be displacement. Displacement cares about where you started and where you ended. Okay, so red, the displacement, cares about where you started and ended, does not care about the middle, does not care about the journey. And then your dark blue, I think is dark blue, might be purple, is distance. And distance cares about the start, the end, and the journey, okay, where you went along the way. So, last but not least is our meaningful equation. Meaningful equation, some of you guys have been doing a great job with this, some of you have been struggling with it, so let's see what we can do, okay? Now, meaningful equation. Our equation for any linear line is y equals mx plus b, okay? Now, there's probably going to be a portion on the test that I'm going to ask, include numbers in your explanation or include numbers in your meaningful equation. So I'm going to include numbers in my meaningful equation. So with that being said, we're going to start with that y. You have to look at your y-axis and you got to see what are we measuring for our y-axis. Now, if I look for our y-axis, okay, y-axis, we are measuring position in meters. So I'm going to say y is going to be meters. That's the unit we're measuring for our y-axis. So I'm going to insert meters in for y. Okay. Next, I'm going to skip to x, our x-axis, because that one's a lot easier to deal with. Then we'll deal with probably m and b. So what are we measuring for our x-axis? For our x-axis, we're measuring time, okay, specifically in seconds. So I'm going to put seconds here. Okay. Now, m is your slope. Okay, so m stands for slope. M is when you put your y over your x. Okay, and so we already found y. Y is meters. And we already found x, that's seconds. So our units for m is going to be meters per second. But I already found what the slope is, okay? For a position over time graph, your speed / velocity is going to be your slope, specifically velocity, a little bit more accurately. So your velocity is going to be your slope. And we already determined the units meters per second. Your velocity, average velocity was -5 meters per second. So right here, I'm going to insert that number. Okay, like I said, we're going to insert numbers. And if I ask you to do so, please make sure to do so on the test. Our slope is -5 meters per second. Okay, -5 meters per second. We already solved for that. Your velocity is your slope. It's -5. Okay, we know it's negative because the position over time graph is going down over time. And we know it's -5 because we did the math on it. Your displacement was -40. Your time was 8 seconds. -40 divided by 8 is -5. Last but not least, what is your b value? Your b value is your y-intercept. Where did you start? So where did I start in this graph? Well, your y-intercept is when your x equals 0. So my x-axis down here, when that equals 0, what's my y? It's 40. And you got to be careful. I saw a lot of people making these mistakes. A lot of people don't label the unit on this. It's 40 what? Is it 40 time? Is it 40 students? It is 40, since it's on the y-axis over there, since it's on the y-axis, okay, this is going to be 40 meters. Okay, so this is an example of a meaningful equation. Your y is your position / meters. Your slope is your y over x, so it's your meters over second, and we already found it, okay? We found the numerical value, which was velocity. Your velocity was -5, so that's your slope, -5 meters per second. Your x, you're measuring seconds, that's time. And last but not least, your plus b is your starting value, which was 40, but do not forget that unit. It's 40 meters, okay? Make sure to get that one. So, meaningful equation, average speed, average velocity. Now, let's try another graph, okay? Another position over time graph right here, all in red. So I'm gonna take this, I'm just gonna scoot this out of the way. Scoot you guys over here. Beautiful. So here's a position over time graph. So we have some object is moving backwards behind the starting line, then it stands still, then it moves forward and crosses the starting line, then it stands still again, moves backwards toward the starting line, and then it stops at the starting line and just stands still. Okay, so I'm trying to draw in red just so you can see that I drew over the line there. Okay, so when was the object traveling the fastest? Okay, so fastest, speed, position versus time graph. How to determine if an object is traveling the fastest? The easiest way is by looking at which is the steepest line. Okay, steep means more vertical. Okay, this line is much more steep than this line. Okay, this one's much more vertical. So I have to look at this graph and I have to decide, okay, well, where and what region was the object moving the fastest? Now, I would say this line is kind of more horizontal. If it's more horizontal, then it's slower. And I would say this one is pretty horizontal. This one is horizontal, and that means it's the slowest. And the slowest thing that can exist is something that's still, something that's stopped. Okay? Now, this one looks pretty vertical, so that might be the main contestant here. Right here, we are stopped, so that's slow. Right here, we're steep. We're definitely steep. It's definitely, it's like a mix of horizontal and vertical. It's pretty diagonal. So that one's probably a good contestant. And then we have horizontal again here. That means it's still and it's stopped. So my real two contestants that I'm going to be looking at are these two regions. So region 1 and region 2. Now, a lot of you are probably moaning and groaning because you probably know which one is more steep. And by looking at it, you can figure out which one is more steep. But you could also figure it out by looking at what the slope is of the object. Okay? So for example, right here at this starting position, we're at -4 meters. And then within 1 second, we go from -4 meters up to 4 meters. So we traveled 4 meters again. So in 1 second, we traveled 4 plus 4, which is 8 meters. Our slope there is 8 meters per second, specifically in the positive direction. Now this object over here in region 2, it was traveling backwards. It was at the 4 meter spot. So this one was at the 4 meter spot. Within, what was that, 2 seconds? It traveled -4 meters and went backwards, and so has a slope of -2 meters per second. Okay, since this has a very small number for a slope compared to this, 2 is smaller than 8. That means region 1 had the steepest and or fastest traveling time. So when was the object traveling the fastest? Okay, if I do label these, if I label this, like let's say I labeled this region 1, you could say region 1, but I'm going to specifically say the time frame. From 3 second to 4 second, that's when the object was traveling the fastest. So the object was traveling the fastest from time equals 3 seconds to time equals 4 seconds. Okay, that's the most steep line. And so that means that was the time 3 seconds, 4 seconds when the object was traveling the fastest. Now, let's try this next problem. What was the average speed for this object throughout the entirety of the graph from time 0 to time 10 seconds? Okay, so in order to find the average speed, we need to find distance because speed is calculated by distance divided by time. And again, like I stated before, to find the distance, you need to find how much of the how far did the graph travel down and up? Okay, we don't care about left and right. We just care about how far did it travel down, how far did it travel up. Okay, so let's see. So if I zoom in on the graph here, we're going to try to see how much it traveled. So we started at 0, and then we went to -4 meters, okay? So that means we traveled 4 meters, okay? Distance does not care about positive or negative. So we started at 0, we went to -4, we traveled 4 meters, okay? Right here is horizontal, we didn't travel any meters, and again, I didn't say I cared about left and right, I just care about up and down. So we traveled 4 meters down, we didn't go up or down right here, so I'm going to ignore this spot. Right here to right here, from 3 seconds to 4 seconds, we went from -4 meters to positive 4 meters. That means we went up 8 meters. From here to here, we stayed in the same position, okay, and we didn't go up or down, so I'm going to ignore that region. From 6 seconds to 8 seconds, we went from 4 meters down to 0 meters, so that means we traveled 4 more meters. And then from 8 seconds to 10 seconds, okay, we didn't go up or down, so I'm going to ignore that region. We didn't travel any meters. So the total distance traveled was 4 plus 4, which is 8, plus another 8, which is 16. So we traveled 16 meters in the time of 10 seconds. So our average speed for the entirety of this graph was 16 meters divided by 10 seconds, which is 1.6 meters per second. And I do not care about the plus or minus. Okay? Do not care about the plus or minus. Now, how is your average velocity different? For average velocity from 0 seconds to 10 seconds, we need to find the displacement. Displacement over time. And I know my time is 10 seconds. We've covered that part already. Now, what was my displacement? Again, displacement does not care about the journey. We're not going to travel the entire line, go up and down. We just care about the start and the end. So we started at 0 meters. We ended at 0 meters. So to calculate for displacement, you need to take your final position. So final position minus your initial position. So we're going to take final minus initial. And it so happens that our final position was 0 meters. Our initial position was 0 meters. 0 minus 0 is going to be 0 meters. And then if it was 0 meters, 0 minus 0 is 0. The question is, what is 0 meters divided by 10 seconds? Our answer is our velocity was 0 meters per second. Okay? You don't care about the journey. You just care about the destination. And based on this, remember, your x-axis here for your position or time graph, this is the starting line. This person started at the starting line, and then they ended at the starting line. Okay? Their position didn't change. From the beginning to the end of the graph, they start at the same spot as they ended. Okay? So keep that in mind for displacement. Starting and end. For distance, we care about the journey. Okay? We want to go up and down and measure all the times in between. Ooh-wee. Okay, we're almost done, people. Great job if you made it this far. We only have one more thing to cover, and you guys should be in a pretty good spot. Okay? I do want to highlight this velocity over time equation. Okay? You don't have to memorize this equation. It will be on your test, but we do want to cover it. Okay? So an example problem for this is a car is traveling 76 miles per hour and just passed the 80-mile marker. A little while later, the car passed the 65-mile marker. How long did it take the car to reach the 65-mile marker? Okay, so what we're going to try to solve for here is time. Okay, we're going to be solving for the time variable. Okay, so I'm going to go through and I'm going to label what each of these letters stands for. Okay, so X here stands for a specific position. Okay, I'm going to label which position that stands for when we get there. We have another X over here, so this also is talking about a specific position. And then we have V, which is right here, and V stands for your velocity, aka your speed and direction. So, how are these two X's different? X of 0 means when time is 0, what is your X position? Okay, aka what is your starting position, or what is your Y intercept? Okay, synonymous terms for this equation. Starting position, y-intercept, same thing. Okay. Now, how is that different from this position over here? Okay, this x is going to be your final position. Where did you end up? okay? And we have numbers we can put in pretty much all of these variables, okay? So we have a value we can put in for all of these variables. So first of all, let's try to identify which numbers go where. So it says a car is traveling 65 miles per hour. Well, miles is a variable for distance, okay? It's a unit for distance, and then hour is a unit for time. So distance over time or displacement over time is either measuring speed or velocity. In this situation, we're going to be putting that number 76 in for velocity. So I'm going to put 76 miles per hour. Okay? And we're going to put T for time. That's what we're solving for. It said we just passed the 80-mile marker, so we're starting at the 80-mile marker. So that's our starting position. So we're starting at the 80-mile marker. And then it says a little while longer, we reach the 65-mile marker, which is going to be our final position, 65 miles. What is the time that it took to reach the 65-mile marker from the 80-mile marker, given our velocity? Now, our equation is almost done, but you have to ask yourself, okay? We started at the 80-mile marker. We went to the 65-mile marker. Am I going forward or backwards on my position over time graph? If I were to plot my travel, okay, my distance over time, if I were to plot this, am I going down on my graph or am I going up? And you should know your starting position was 80 miles, 65 miles is your ending position. You guys are going down. And since you're going down, your velocity must be negative, okay? You have a negative velocity because you are starting at a further away position than you're ending, okay? Since we started at 80, you're ending at 65. If we were to graph this, on a position over time graph, you're starting at the 80-mile position, and then you guys are ending at the 65-mile position, okay? This is what your graph would look like. This is where you ended. This is where you started. How much time did it take to go this distance? That's what we're finding. Well, we have all the variables solved for except for t time. So we're going to solve for time, okay? So to solve for time, we're going to first try to separate all the other values away from t time. So first, what we're going to do is you can do the order of operations, okay? So we're going to be undoing a lot of this stuff. So this negative 76 is attached to t, so we're going to deal with that last. On this side of the equation, the most, or the number that's most far away or the least attached to time is the 80 miles, okay? So we're going to first move this 80 miles over. So if we're adding 80 miles on this side, to undo that, we're going to subtract by 80 miles on both sides. So subtract by 80 miles, subtract by 80 miles. Now, if I do that, on this side, I'm going to have negative 15 miles equals negative 76 miles per hour multiplied by time. Okay, so now we have negative 76 miles per hour multiplied by time. How do you undo multiplication? We have to divide. And so now what we have to do is we have multiplied by negative 76. We have to divide by negative 76 miles per hour. Divide by negative 76 miles per hour. And since we're dividing now, since we're dividing now, we can actually start canceling out units. Okay, miles cancels out miles, hours cancel out hours, miles cancels out miles. Okay, so our final answer here is going to be negative 15 over negative 76 hours. Okay, negative 76 1 over hours, okay, will equal t time. Well, I don't want a decimal, so we're going to work on this. We're going to input this into a calculator. As well as our last unit here is hours, and we have a fraction in a fraction. So 1 over hours, you can simply undo this by just moving hours on top, and our final answer's unit will be hours. So our final answer is going to consist with hours being on top. So our final unit for time is going to be in hours. And also you should know that because in the problem, it says we're traveling 76 miles per hour. Miles is our distance, our measurement for distance. It's our unit for distance. Hours is our measurement for time. So we're going to have to be in hours. Okay. So the question is, what is negative 15 divided by negative 76? Fun fact, since there's two negatives, we can cancel them out. Our final answer is going to be positive. Our final answer will be positive. So I'm going to take my calculator, which you will be allowed to have on the test. We're going to have 15 divided by 76. My final answer is, I'm going to take this, I'm going to move it, put these lines, beautiful. We have 0.197 hours, okay? So it's about a fifth of an hour. So, what is that going to be? I mean, if you just take your hours and if you multiply it by 60 into minutes, that means it's roughly going to take 11.8 minutes to travel from the 80-mile marker to the 65-mile marker, okay? So with that being said, I'll try to separate this into chapters based on whether you need help with the velocity over time equation, if you need help with the meaningful equation, or if you need help with average velocity, average speed, or if you need help with turning position over time graphs into velocity over time graphs, okay? So I'm going to try to get this uploaded before the test, obviously, so it's helpful for you guys for studying. Otherwise, I hope you guys email me if you have any questions. Let me know if you have any concerns or if you notice any mistakes in the video. I'd love if you corrected anything. That means you're paying attention. With that being said, good luck on your test. I hope you guys use all your resources and study up. Okay, bye-bye.